Dr. Edward Teller, one of the most noted atomic scientists in the world, a man of extraordinary achievements and recognition. And Dr. Teller is with us today to discuss a remarkable approach to the problems of nuclear energy, an approach which he and several of his colleagues, Dr. Raskovsky of Israel, have been working on for at least 5 years, and an approach which may indeed answer the problems of nuclear proliferation and perhaps some of the problems of atomic waste material and safe energy for mankind. Dr. Teller, why is this thorium reactor so different and so much more valuable than ordinary forms of uranium or ordinary forms of atomic energy as we know it today?
Actually, ordinary forms of atomic energy are quite valuable. This fact is fully recognized in many places, for instance in France. Unfortunately, it's not sufficiently recognized in the United States. But my student, Raskovsky, he was my student before the Second World War, long time ago. He has a new approach which has two very great advantages. One is that basically it is using not uranium but thorium.
Yes.
And there is much more thorium around in the world, 5 times as much as uranium. And furthermore, in the usual kind of reactors,
Yes.
we are not utilizing more than about 1% of the uranium, whereas thorium is being utilized 100%.
A remarkable difference.
There is altogether a difference of a factor 500 in availability. So if in the one case you may argue that if we all use it a lot, then we may run short of uranium in 100 years.
Yes.
Then the same argument will tell you you are going to run short of thorium, not in 100 years, but in 50,000 years.
That's a remarkable difference.
That's quite a little difference. Of course, a part of this advantage could be attained with the breeder reactor, which utilizes uranium fully.
Yes.
But here comes now a second difference. The thorium reactor is less expensive than this breeder reactor. In fact, it competes quite favorably with present type of reactors with which we are already familiar.
Yes.
It utilizes all the experience we have gathered about reactors. And now there comes one last difference.
Yes.
And that is that this reactor is practically proliferation proof. If you use it and sell it to India or Pakistan or whatever country you like, there will be no real danger that the material will be diverted to make atomic explosives. It will serve the peaceful purpose and only the peaceful purpose.
Then, by the use of this new thorium reactor that you have conceived.
I haven't. Raskovsky has.
Give credit where credit is due. By use of this new thorium reactor, we would actually be able to prevent any underdeveloped nation from utilizing the byproducts to create atomic weaponry, and therefore could probably call a sharp halt to proliferation.
Well, in actual fact, you are now asking for too much, because there are many ways, not involving reactors,
Yes.
by which proliferation could be achieved.
Mm-hmm.
We are not going to halt proliferation quite so simply.
I see.
But what we are doing is to separate the issues.
I see.
The spread of nuclear reactors, if it is that kind of a reactor, will have practically nothing to do with proliferation.
I also, you made a statement that the waste material from a thorium reactor, it's safer to handle than those from an uranium reactor. Is that correct?
The waste products can be handled in part in a similar way as they are being handled now.
I see.
In part,
Yes.
the waste products, and in the later part, the waste products need not be handled, but can be just put underground and forgotten. If you try to solve the materials problem, the availability of fuel,
Yes.
with the help
Yes.
of thorium, as we plan it, but by using thorium according to usual approaches, entirely new methods of materials disposal have to be invented.
I see.
We know how to dispose of the material if we use uranium. We also know theoretically how to dispose of it if we use thorium.
Yes.
But the thorium disposal has not been solved, except in the laboratory. It has not been solved on a big industrial scale, and that would require years. Now, the ingenious part of Redkowski's proposal is that the new methods that would be required for the disposal of the thorium byproducts
Yes.
is being sidestepped. You use the thorium input and burn it up to such an extent that what is left you can just put underground. You don't need to erect an extra plant to chemically separate, with all the complications and also dangers which would result in such a new type of separation process.
Well, if the thorium reactor is indeed less expensive, less capable of causing, its use for atomic weaponry, and is safer than an ordinary uranium reactor, what is preventing us from going ahead and using thorium in all the atomic plants that are built? Is a thorium reactor, can it easily be adapted for use in ordinary nuclear reactors as they are today?
With a little difficulty, not quite easily.
Mm-hmm.
If you take a finished reactor today and want to convert it into a thorium reactor, in certain types of existing reactors, this is easy. In other types of reactors, it's harder. In each case, it needs some effort. One should realize that the new reactors promise to be safer, but the safety question still has to be discussed in all its detail. I have no doubt that on the whole, this new type reactor will represent a great deal of progress. Unfortunately, in order to get it going, not terribly much capital will be needed,
Mm-hmm.
but some will be.
How much will